Hi, everyone. Thank you for coming to check out my poster. So I'm going to talk today about manganese biocontamination and passive remediation systems that are treating abandoned coal mine drainage. So to get us started, here's some background on manganese-based stability. This means that manganese can be found in different chemical forms based on the pH that's present in. And what we're most interested in is the aqueous form of manganese, Mn2+, because this is the form that's water soluble. So this is the kind that will enter the watershed and pollute the local environment. Manganese can be found in these different oxidation states based on the gain or loss of a reduction through oxidation reduction reactions. And microbes can help drive this. So we're really interested in knowing which microbes are present in these passive systems so we can determine who is contributing to this bioremediation, which is positive, or this biocontamination, which is negative. So to do this, we go out to our system and we collect pond water slurry that we then bring back into the lab, and we plate on these special plates to identify isolates that are involved in manganese reduction or oxidation and confirm that they breed true. We then screen them in the EPA FAD assay, which measures the amount of manganese in solution, so we can see how much manganese reduction they're causing, as well as in the future send them for 16S sequencing. So Boys Park here is an acidic system. It has several ponds that flow through it. The direction of the arrow shows how the water moves. The levels of manganese in the system, although they do slightly decrease as they exit, they, however, do not meet the minimums for EPA limits of 0.05. So they're still above limits, so they need to be addressed in some kind of way. So we assess the geochemical reduction of manganese in this acidic system by adding manganese oxides to sterilized pond water. And we see there's about a 10-fold increase of resolubilized manganese geochemically, or about a 850% increase between day 0 and day 5. We then use these really cool manganese plates to identify manganese reducers and manganese oxidizers. Manganese reducing plate starts out with this brown color, and then you'll have this clearing if they're capable of reducing manganese. The manganese oxidizing plates start out clear, and then they'll have the development of brown precipitants if they're capable of oxidizing manganese. So we didn't find any manganese oxidizers in the 149 places that we screened. So if they are present, they're present in a frequency of less than 1%. However, we did find manganese reducers throughout our system, and we isolated 64 candidates. Of those 64 candidates, we then tested them in sterilized neutral pond water, and we found that they are capable of increasing the amount of solubilized manganese. So yes, in the system, this is biocontamination, which is bad, which hurts the environment. However, if we use these reducers in a controlled setting, we can actually use them potentially for biomining of elements that have co-precipitated with manganese. So in this instance, we've looked at carbon stimulation, or adding something to increase its metabolism, and we can see that we can stimulate the growth of these isolates with supplementing in 10 millimolar lactate. So we know that we have microbes in the system. We have 64 potential candidates, 5 of which have been purified and confirmed in the FAD assay. Going forward, we would like to do more replicates for statistical analysis, as well as identify these isolates via 16S, and you send unique ones for whole genome sequencing, as well as purify and confirm the additional isolates we have in the freezer. Thank you.